Oh, welcome back. We're here with another math video, so that's pretty exciting. What we're going to do right about now is we're still doing rational functions, and the process at this point in time is to move in the reverse direction. Okay, we are going to, rather than given an equation, come up with the mapping notation, then sketch the graph. What we're going to do is we're going to work backwards. We have a graph. We're going to come up with the mapping notation, which will lead us to the equation. All right, so we're going to move in the reverse direction. So as we do this, first of all, you want to recognize that yes, this is a rational function because of course you have a horizontal and vertical asymptote, and your graph is broken up into two separate sections, and we're given the key points. So what we can do is, first of all, let's remind ourselves that on the left here, okay, this is the original rational function, the most basic rational function, y is equal to 1 over x. This is the original one that we're going to compare every other rational function to. So when we take a look at vertical stretches and translations and things like that, we're looking at this graph on the very left. How has this changed into this new graph right here? Okay, so it doesn't really matter if you start with stretches, reflections, or translations. Doesn't really matter the particular order, but what I'll do is I'll do the translations first because you can get those from the vertical and horizontal asymptotes. So you can see in this original function right here, the basic function in the left corner here, you can see that the asymptotes are the x and y axis. So we want to see how has those axes been vertically shifted, horizontally shifted, things of that nature. So if we talk about horizontal translations, we're actually talking about the vertical asymptote. Okay, so once again, it's easy to get confused, but the vertical asymptote is a vertical line, but you're gonna shift that left or right. So you're taking a vertical line, but you're shifting it units to the left or units to the right. So if we take a look at this right here, we can see on our new graph that the vertical asymptote is at x is equal to -3. Okay, so we have a vertical asymptote. So we know that the original vertical asymptote, which was originally the y-axis, that has been shifted 3 units to the left. So we put in our vertical asymptote here, and similarly, we put in our horizontal asymptote here, which is also the vertical translation, and vice versa. Okay, so we have a horizontal asymptote. It's a horizontal line, originally the x-axis, but we are shifting it up or down. So we're moving it or translating it vertically. So you can see right here that the new vertical asymptote is at y equal to 4. And by vertical asymptote, I mean horizontal. Okay, so you can see that what used to be the x-axis has been shifted up 4 units up. So what we can do is we can put in our vertical translation, which is the same as our horizontal asymptote. Okay, so we have translations out of the way. Next up, we can take a look at reflections. And reflections, you can just look at visually. Look once again at your original basic rational function. You have sections of the graph in the upper right and lower left. Has that changed? Yes, it has. Now you have it in the lower right and upper left. So it looks like it's flipped over the x-axis. So what we can do is we can put a negative on the y. That's a reflection. When the y is negative, it's a reflection on the x-axis. Now the thing about these graphs is you can say that the reflection is along the y-axis instead. It produces the same result. So if you wanted to, you can make the x negative instead. But one thing you'll notice is about these rational functions is we never have a horizontal stretch factor. So I kind of just leave that x alone and apply everything to the y. But if you made it a negative x instead, and then your equation reflected that, that would be okay. So we determine that there's a reflection. It flips over the x-axis. In terms of stretches, here's what you want to do for stretches. Okay, you want to look at the key points, and you also want to look at the intersection of the two asymptotes. So if you look on the left here, all right, the intersection of the two asymptotes would be here where the x and y axes intersect. And to get to either of the key points, you would move 1 unit to the right, 1 unit up. Or you'd move 1 unit to the left and 1 unit down. Either way, you can get to the key points by going horizontally 1 unit and vertically 1 unit. Let's take a look at our new graph and see how that has changed. The intersection of the two asymptotes is right here. So to get to either one of the key points, you would go horizontally 1, vertically 2. Or, once again, horizontally 1 and vertically 2. So instead of doing going over 1, then up 1, you're going over 1, up 2. So we've doubled the amount of times you have to go up. The vertical stretch is 2. You've stretched that original graph vertically by a factor of 2. At this point, once you have the mapping notation, you can easily come up with the equation. Okay, the y's stay the same, and the x's, we change the sign of what comes after, and we now have our equation, and you can check your answer in Desmos.